Good morning, and thank you all for joining us today. Welcome to Microsoft Reactor livestream event. My name is Rashmita, and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 3 hours, including Q&A. So please feel free to drop your questions in the chat box. We will try and answer as many as possible. I have already shared the event check-in link with the event ID in the Q&A section, so please feel free to do event check-in. This will give you access to additional resources and information about events that we are running on Reactor, which are around similar topics to today's session. Also, you will be able to access related links to today's session. I will share a link to our feedback survey, so if you could fill that out with the same event code, that would be great. Also, this session will be uploaded straight to our YouTube channel. I would now like to introduce Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and a co-founder at Tech Scalable. He is also Microsoft certified trainer. But for now, I will hand over to Shivam to begin the session. Over to you, Shivam.
Thank you. Thanks for that. Thanks for having me. How are you guys? Good morning to everyone. I hope everyone is doing well. You are safe. So let's get started. Today we are talking about cognitive services and deep learning. And this is basically a workshop. And the way we have structured this workshop is that it will be mostly, you can say, hands on. And I'll walk you through the agenda. And in this workshop, we will be solving one customer case study. We'll understand the case study first, and then we will understand the from the design point of view. How do you design it up, and what are the various Azure services which are coming into picture? We'll understand those Azure services. We will design the solution for the customer, and then we will deploy the solution for the customer. I also have the link of GitHub with me. I will share that GitHub link for you guys to reproduce the same thing which I'm showing later on. So basic prerequisite will be little bit of know-how into Azure, having an Azure account. That's and then you can just you can say do the entire scenario as well. So I'll just walk you through my slide deck over here. And if I just show you what we will be doing is, so basically, let me put the context first. What are we learning today? So the services which we are covering will be Azure Machine Learning Service. We will see what are cognitive services, what is computer vision, what is text analytics, Keras, TensorFlow, and Open Neural Network Exchange, ONX model. What's the use case? Why do we use these things? Why, what, how, everything around these services. Now, by the end of this particular workshop, you will be able to understand the what is LSTM. You will understand how do you create a deep neural network, what is Azure Machine Learning Service, how it comes together, how can we use pre-built AI solution, how can we use some sort of custom AI solution into one scenario. So this is what we are doing. And any questions which you have, you can always put in the chat window. Keep on asking your questions. We will also, try to take the questions on the way. I will also take the questions in the end of the session as well. So both places as such. Now let's get started. So the very first thing we will be doing is we will go through the customer scenario. Now this is the part where you have to sort of just hang in with me and understand what is this customer looking for, what do we have to provide to this customer, what are the pain points, what are the objections of the customer, and the needs and the requirements like that, because we will be answering point by point and we will be deploying and designing as well along the way, right? So the scenario is around one company called as Contoso Insurance, and they basically have so what do? They provide the insurance, they work in the insurance domain, and their headquarters is in United States as such, and their customers are US customers, and they provide insurance, life insurance, travel insurance, home insurance, auto insurance, health insurance, and any accident insurance as such. So they provide all of that. Now the way in which customers interact with this company is that customer can go to their website and they can just claim the insurance over there. This company also have and mobile application. So basically they have that mobile app also, and using that also you can upload the claims, you can upload the pictures, you can write the text as such around that, and so on and so forth. So whenever the customer needs to claim the insurance, they basically have to provide some basic information. So that basic information contains the contact information, the policy number which you have taken, as such. Apart from that, like what has happened, did you had any was it a home accident, or was it some sort of car accident, or what type of accident was there? The customers, they also specify they also upload pictures as such, like before and after pictures, like what was the situation before it, and any previous picture which was there, and then what is the situation of the particular vehicle after the accident. So this is some basic things which uh, the customers have to do to to claim the insurance. Now, so this is where basically like you can have some vehicle insurance and or home insurance scenario. So today we will be creating one binary classifier. So we will be classifying between the whether this claim which has been done, whether the text which is there, whatever the customer has written, is that customer looking for vehicle insurance claim, or is the customer looking for the home insurance as such, what are they claiming for. So this on a very high level, this is what we are doing. And now let's go a little more depth, let's understand what Contoso insurance want us to perform, like what are the main points as such. So there are few challenges which they are facing. So the company basically is coming to you, you guys are the data scientists today, or the machine learning engineers as such, and you are just reading. So imagine that you are reading the scenario, and now you have to design the solution, plus you have to implement the solution as well, like both things has to be done. So the basically this is if we just go through the requirement of the customer. Now, few of the challenges which Contoso insurance is facing will be that it takes time for an agent to read through and process the content submitted for each claim. Like whenever you upload the claim, there is a text which has to be written. Now that text is very long, so it takes the agent a long time to go through it. So they are looking for some sort of summarization. Can we provide some sort of summarization to them or not? Right. So that's one thing which we can think of. Secondly, they are saying that the while all the information is stored in a database, the details about the claim, including the text responses and the supporting photos which are there, are stored as attachments. So uh, there is a database, and in Azure we'll go for relational database, we'll go for Azure SQL. And but apart from that, they also have the pictures and the text files in another location, but that location is non-searchable. So that is very difficult for the agents as such to what do they do? They go to the database, they look up in the tables, and then they find the equivalent number of blobs in the object storage, and then they go to the object storage, and then they search for which picture is supporting this particular applicant, and then they try to make a case around that. So this is something which they're looking for. This is one of the pain point, that things are non-searchable. Do we have anything in Azure which can do that? Now, one more thing. So as we are discussing as we are just walking through or we are reading through the scenario right now, if any of the solution comes to your mind, for example, where can we put the pictures in Azure? So if somebody says that you have to upload the unstructured data in the cloud, in Azure cloud, then where do you put that unstructured data? What are the options as such? Which technology will you go for? Or if you have to create searchable index, then which service do you will you go for? So if those type of questions, like if those answers comes to your mind, or you want to suggest something, just put them right away in the chat window, right? That for maybe for the text, we are going to put here, we have two solutions and Azure, and so on and so forth, right? Now, if I just further go through the scenario of the customer, the customer is also so what they want is that they want us to, the main two pointers in this case study will be that we have to create one system which can classify between that the text which is typed by the customer. What is the intent of the customer, like what is from the utterance of the customer, what is the intent of the customer? Is the customer looking for uh, vehicle or home insurance claim, or whether he or she is doing auto insurance claim based on the text? So text based classification is one thing which they want us to do, right? Second thing which they want us to do is sentiment analysis. They are saying that Contoso Insurance is telling you that if the customer is very angry, if the customer is saying that I this is a very you can say I need immediate help, I'm very angry, your process is so long, and so on and so forth. So if the sentiment of the text is negative, right, it's negative, then the customer care team should come to know of that as soon as possible, because in today's world social media is pretty powerful, right? If the customers are not happy, and if they tag the company on Twitter, then things may go viral, right? So before things go viral, we should be able to you can say get back to the customer and solve the grievance as such. So we should be having, let's say neutral type of claims, and then we may have to classify into that these claims are very negative. So we have to prioritize the claims which are negative first, so things don't go viral on any of the social media platform as such, right? So that's one more thing which the customer is which Contoso is looking for us to explain there. Okay, now, okay, so if we so we have to design the solution around that, right? So in the chat window I can see some of you are suggesting go for ADLS Gen 2, go for blob storage for keeping unstructured data, uh, for Azure Search for making searchable results as such. So others also, uh, if you, for example, if you know which services in Azure can be used or what can be done, so put your answers in the chat, keep on putting that. So the customer is also looking for, so the customer is saying that this is something which I already told you, that the claims are very, the text which is supporting the claim is pretty long. So they want us to summarize, they want us to use some any machine learning library which exists to summarize the text as such. Now they also have questions around that, that whatever pictures are getting uploaded. So, for example, if you upload the picture of your car which had an accident, uh, the machine learning system should be able to tag it. The ML system should be able to understand that whether this picture is even relevant or not, whether this picture uh, is of really a car as such, or is it something, some random picture which the customer has uploaded over there which doesn't make sense. So is it, we have to understand that particular part. We also have to store the tags. So with these tags we'll be making some searchable systems as such. So the tags from the pictures needs to be stored. So these are some requirements which we are reading right now. Now some of the objections which they have, this is where they have interesting objections. So they are asking about that, there is a lot of hype around AI, right? In today's world, there is a lot of hype around AI. So, is AI, can AI even do all this? So, do let me know. What do you think? Can AI perform the OCR? Can it perform the sentiment analysis and all the details as such? So that's one thing which they are looking for, which we have to tell them whether it can do it or not. And is Azure the correct technology of choice, or is Azure the correct platform where we should do it or where we can do it? So which services in Azure are we going to use? That's also something which we have to deploy. Now, okay, now read the third point. So there is a question that there are very popular libraries in the market, right? We have TensorFlow, we have CNTK, there is PyTorch, uh, Keras is also there with TensorFlow backend. Now Keras is part of TensorFlow. So from different companies, from different, you can say the different companies who open source various projects, we have multiple libraries in the market right now. So right now we are comparing TensorFlow with CNTK. So which one should we go for? Whatever we are going for, why should we go for it? Any pros and cons around that? So the customer is also looking for this. They are saying, please help us do that. So this is in a nutshell, this is the requirement of the customer which we have to solve. Sorry. Now, so what I'll do, I'll start drawing the architecture, and the way we will be doing is that see, some of the machine learning notebooks which I have, they take around 15 minutes to deploy. Some of them takes even 20 minutes to run. So what we will be doing as a very general practice, we will be running the code first, and then we will be understanding while the code is running. So we don't have to wait for that 15 or 20 minutes. And I have the entire thing as a backup also. In case we have to look up in the backup also, we'll go and we'll have a look into it, right? So in a nutshell, that was the requirement of the customer. They were looking for all of that. So we have to provide them the classifier. So one classifier needs to be there. The classifier is based on text, right? So text based classifier is supposed to be there. Secondly, they are looking for the sentiment analysis, and they are asking that Azure provide something in that regards or not, right? So let me open my whiteboard, and this is where we will be designing the solution of the customer.
Shivam, there is a question. I think let me post that question here. Okay, there's a question on ADLS Gen 2 blob storage for storing the unstructured data, and Azure Search for searching the data, the blob stored data. Is that correct? I think that was the
The
question.
answer, the answer is correct. So these are the two options which we have in Azure where we can store unstructured data. Now the counter question which I have is, or just to follow up on that, so that the person who answered it is absolutely correct. Those two locations are fine. But now let us know also that in those two locations, how do you differentiate? Like if the customer comes back and says that I don't have time is not the problem. I'm not looking for that HDFS compatibility. I'm looking for that. Time is not the problem. I'm looking for the more, you can say, the lesser costlier option. Then which one should we go for? Or in general, anyone help me answer that. ADLS versus object storage, Azure blob storage. How do you differentiate to your customers? Tell the answer in the chat. Right.
While they do that, you can continue with
Okay. Sure.
question. Yeah.
Okay, so check this out. Now, what we are doing, we are designing the solution for the customer, right? So we will be talking about Azure services. Now, those who already work in Azure, you will have a little easier time because you will be familiar with the terms. For others, just hang in with me, right? And I'll try to explain, and we'll deploy it anyways in some time. So let's understand the design first, so the deployment will be easy to follow. Uh, right now, check this. So the customer is already having uh, the web app with them. So we are not touching the web app. The web app still exists. Now in Azure, the web app is basically part of app services. So we'll create one app service plan. So let's say this is the app service plan, right? Now inside the app service plan, the website already exists. So that part already exists with the customer. We don't have to change anything which is already existing. We don't have to reinvent the wheel. We have to enrich the data which they are already collecting, right? So imagine this is the website already running, perfect, amazing in Azure App Service Plan. This is the web app running. So web app over there. Now, okay, so the data is going in the object storage. So we are putting the data in Azure storage account, which is an example of object storage, and in blobs, in containers, right? That's where we are putting the data. So the all the claims and the text, everything goes at the backend in this storage account over here. Now we are not going for ADLS right now. The reason why we are not going for ADLS is that ADLS is replacing HDFS in Azure. Like it is that in the big data ecosystem, it is the HDFS layer which on top of which you create your Hadoop and Spark cluster. Now storage accounts are 500 terabytes in size. Data lake is having no upper limit. You can keep any amount of data over there. So if the customer really wants to, is really looking for that big data storage location, like replacement of HDFS where there is no upper limit, they want to implement true data lake, then we definitely can go for ADLS. But the only thing which you have to keep in mind is ADLS is you can say give or take around 5 times expensive than storage account, like minimum. It may be more than that. So really, this is something where you have to keep that in mind. So this is a storage account which we are going for, and in this storage account you can keep 500 terabytes of data, and all the unstructured data will be thrown over here. Storage accounts are amazing, really. They can keep any type of file format, but right now we are just considering them to keep the unstructured data like txt files, or maybe we have some sort of pictures which are getting uploaded. If the customer uploads the house fire picture, or maybe the broken car and so on and so forth, then that's what we are going to put over there, right? Secondly, the structured data will go in relational database. So this is where we have that OLTP system, and we are going for Azure SQL, which is again another PaaS solution. So this one over here. So it is running in that logical SQL server. So this is the logical SQL server, and that is Azure SQL. Now, let me just put it over here. So this part of the solution already exists, right? Like that. Now we are going to create the enrichment pipeline, which is going to work with the AI part. So this already exists. Now we will put in the enrichment pipeline. So the solutions which we are going to use is, we are using multiple Azure functions. Now Azure functions are serverless in nature. They are on demand. Whenever they run in the consumption based plan, then we have to sort of pay for them. So imagine this is one Azure function which we have over here. Now if you are aware of serverless, if you're not aware of serverless, let me know. I'll further tell you a little more about it. But this is where we have those Azure serverless functions in the consumption based plan. And what they will be doing is, whenever the data is getting uploaded in the blob storage, they will be processing that image. So let's say this image over here, it is getting processed. Now in Azure AI ecosystem, there are multiple type of solutions which we have. So let's jump in the AI ecosystem now. So this is the AI ecosystem of Azure. So we have three families of solutions over there. The first family is called as pre-built AI solutions. Right. These are ready-made solutions which are already, you can say, trained by Microsoft data scientists, and they are uploaded. You basically any developer can use it. And the name of the service is called as cognitive services. So cognitive services. We have more than 28 cognitive services. Today we'll be using 3 or 4 of them as such. We'll see what do they do, how do they work, and so on and so forth. Now, when you work with cognitive services, these are developer friendly. Any developer can use that. So the way they are deployed is, let's say this is Azure. This is your Azure subscription, any of the Azure region, and you have deployed this cognitive service over there. Now there will be an API endpoint, and any product can do API call with that and get the inference in the output. So let's say the y dashes are coming as such. Now so there are two modes of deployment. First is called as a cloud deployment. You deploy in the cloud. The only problem is that now you need to have internet connection from the edge device to be able to use the or consume the models. So the second thing which we can do is, we can also deploy these models in the edge itself. So deployment in the edge means, like, you deploy this in the mobile app, or maybe you deploy this in your browser as well as a JavaScript machine learning model, or you deploy in your IoT devices as well, right? So anywhere this can also be deployed locally. So we can have the local edge deployments. So something in this manner. So two modes are there. Now cognitive services are of multiple types. What I'll do, I'll show you the easiest cognitive service to understand. We will be using the others as such. So I'll just show you this one. See, this is already from Microsoft's. It's their own ready-made demo. You can just Google for it and you can have a look at it. Right, look up in any of your favorite search browser. Now check this. So if I just say start, it's gonna convert my speech into text, and then I can create any sort of speech recognition. Oh, let me see if I can refresh the page once. Okay, so let's see. Let's try this now. So okay, now it's pretty explanatory, right? What's going on? It's converting speech into text in real time, and the model is running in my browser right now. So I don't even have to deploy this in the cloud. So the delay, the latency is near. You can say it's real time. And if you create any chatbot which is speech oriented, this is the first thing which you need to do. So there is no need to reinvent the entire wheel. Just deploy these models locally and use them. Right. So this is one type of cognitive service, and we have around more than 28 now in multiple families, like in vision family, in speech family, in language understanding. There is a very popular cognitive service called as Lewis, which we use when we create chatbots. So right, all these are available. So this one, if you're looking for, just look up for this in any of your search browser, speech to text cognitive service. Now the second family of the AI solutions in Azure can be are called as custom AI. So now custom AI are basically where the problem statements are not horizontal, those are vertical. Now vertical problem statement basically means that you have to like this is something which is specific to your company, it is specific to your scenario, your data is pretty specific. The pre-built AI is more of horizontal products, like which any company can use, speech to text any company can use, image analysis any company can use, and so on and so forth. So this is where we have the solution called as Azure Machine Learning Service. So Azure ML Service, like that, right? Like this. So if you are already working as a data scientist somewhere and your company is using Azure, then that's what you already are using, right? Azure Machine Learning Service. And Azure Machine Learning Service already connects with everything which we know of. Like for example, it connects with Azure Synapse as well. It connects with Azure Databricks as well. It contains native inbuilt compute services. So you can deploy, you can have CPU, GPU server, you can have data parallelism over there, you can have model parallelism. As such, you can deploy all those solutions, right? So custom AI solution which data scientist will be using right now. So Contoso Insurance is looking for these two. They are saying that can we use some of the pre-built AI solution, or can we suggest some pre-built AI solutions to them? And secondly, we also have to create some custom AI solutions to them. For their particular requirement. And just to complete this diagram, the third type of family which we have are called as conversational AI. So conversational AI. Now these conversational, basically these conversational AI are called as bot service. Like with Azure Bot Services, we do that. Let me write it properly, like this. So what do we have? Azure Bot Services. So today we are not concerned about Azure Bot Services, and we have multiple sessions. Maybe you can look up in any of the previous sessions or maybe any upcoming session to have a look at that. Azure Bot Services. Now these bot services, the AI part in the bot services come with either custom AI or it comes with cognitive services. So what we are doing is the Azure function is picking up the pictures from the storage account, like the pictures of the insurance which uh, you want to claim or someone wants to claim. It is picking up the picture from the storage account, and as soon as it picks up the picture, there is a cognitive service which we will be deploying over here. So let's say, so this one is called as basically computer vision over here, right? And the picture will be sent to this computer vision, and we will be getting some the outputs from that. Now what computer vision can do, computer vision can literally do OCR for us. Computer vision can do the tagging, it can do object detection, it can find those boxes in the entire you can say scenario. So this is where that cognitive service, one type of cognitive service which we are using, will be this one. There is one question in the chat window saying, I want to use Azure Cognitive Services. My application database is on premises SQL Server, not logical SQL Server. How can I run Azure Cognitive Services over text of the database? Now, see, these cognitive services can also be you can be containerized, and those Docker containers can also run on premise. But the good thing about SQL is, in SQL, uh, the ML is already part of the SQL offering now. So I don't even recommend cognitive services. Just go and have a look at the SQL documentation and see. So the concept is called as, like, we don't take the data to the models, we take the model to the data itself. It's already part of SQL, so look up in the documentation. Now, okay, so first of all, we, from the computer vision, we get somewhat data as such. We get the tags, we get descriptions, and so on and so forth. So now we will have another Azure function over here. The second Azure function, what it will be doing is, we have to create one custom machine learning solution for Contoso Insurance. So the claims which they are putting, the text as such, like this is a text classifier. So text classification over here. So there are two classes right now with us. We will be going for auto classification and home as such. Auto versus home. So binary classifier and text classifier. So this Azure function will do the inferencing around that, right? Something in this manner. So we'll get the y dashes from there. So this text, this the second Azure function which we have will pick up the input will be the text claim, or the text which is supporting the claim coming from the customer. Like, I was driving on and there was a red light, I stopped on the red light, but the other guy jumped the red light, hit me from the left side, right side, and so on and so forth. Now I'm looking for the insurance claim. That type of text, right? That's what we are doing. So from there we have to understand whether this is uh, they are looking for some vehicle insurance or what, like to which department do we have to assign that. The third thing which we are doing is uh, there is a question in the chat, why don't you use Ubuntu? Everybody, we also use Ubuntu to do machine learning. uh, it's not why don't you use, we use, right? There is nothing like we don't use Ubuntu. So, right, okay, check this out. Now basically what we are doing is, the third thing which we have is that we are going to do the sentiment analysis. So the third machine learning model is again going to be a cognitive service over here, which already exists. Like, we don't have to create. So if the wheel already exists, we don't have to reinvent that. So we are going to use sentiment analysis like this. And this text which is there will be sort of scored against that service, and the y dash will be a score between 0 and 1. So the sentiment analysis of Azure gives the score between 0 and 1. 1 means a very positive statement, 0 means that you are pretty angry, right? That's the meaning of 0 as such. So on a very high level, this is what we are doing. Like, we will be using the pre-built AI plus the custom AI to cater the request, to cater the needs of this customer. And we are using, we'll also suggest that we can have Azure Search. So this is Azure Search over here for indexing. So this Azure Search can create multiple indexes as such on the, it can crawl through the databases, it can crawl through the storage as well, it can create those indexes for you. So this is what we will be deploying now. Now, in case you have any questions, feel free to answer, or feel to ask. I'll answer them. And let me just have a look at if there is anything which is left, because I will be opening my Azure portal now, and I'll start sort of deploying, and we will understand in more depth. We'll see what we are doing, how do we do it. And today we'll be focusing on the machine learning part, right? Cognitive services and machine learning. So that's the major focus. Okay. So now the GitHub link of the deployment. So those who want to do it with me or afterwards and so on and so forth, feel free to do it. I will just put the GitHub link in the private chat, and anyone from the team can uh, put that in the comments in right now, maybe in some time as you wish, for everyone to reproduce the demo afterwards, right? Okay, so this is my Azure portal, and basically I have this. What we will be doing is, we will be creating the infrastructure which is required. So if you see, we need the machine learning service. Now, this text classification model has to be created in Azure Machine Learning Service, the custom AI, right? You see this purple cloud which we have over here, and we need two cognitive services, computer vision and sentiment analysis. So these two we require, and one custom machine learning as well. So three things we need to deploy. So what I'll do, as I was saying, that I will start running the code first, because some of the notepads, which the notebooks which I have, will take a longer time to run, and I'll explain in more depth while they run. Right. I have already deployed everything as a backup over here with me. So in case we have to look up in the backup for while the code runs, we'll just go through and have a look at it. Right. So let me get started. So I'm creating one resource group as such, and this is so let's say workshop live, just for me to differentiate, and we are deploying this in east us. Let's create that. Now inside that, we are deploying custom ai and two uh, cognitive services. Right. So let me do it over here. So I'll just duplicate my tabs so I can do things parallelly, and I'll try to be as slow as possible. But if you are new to Azure, then just have a look at it. If you already know Azure, then you can keep up with me, right? So have a look at this. So I'm looking for that machine learning service. Now Microsoft is very straightforward with the names. They don't have very fancy names for the service. They actually put the same names as what the service does. So machine learning service is machine learning service as it is, right? Now we are deploying one workspace now. So let's say let me just put live demo so I can differentiate between my other one and this one, so I don't get confused later on. And this is an east us. I don't need the container registry right now. It's fine. So this is coming up. We'll just click on create. Oh great. Now apart from that, we want one computer vision. Sorry, let's see if the name is available. Pricing tier. So this is in case like you're thinking how do we consume it. We have like the costing is api call based. So we are just selecting the one which will not say that you have to wait for more request, right? So it will have a higher throughput. So we'll go for the standard one. Okay, in the meantime, I'm just deploying the third service. uh, uh, so you see this app service plan. I was thinking of one thing over here. Now can someone help me answer that? In Azure, when you create these app service plans, which is the minimum app service plan which is production grade? Like, do you know that? Like when you go for the app service plans, which is the minimum production grade plan, the minimum one, not the maximum, right? The minimum one. Answer that. In the meantime, I'll just go back to my Azure portal and I will look for the text analytics, and I'll quickly deploy that. Oh, I don't want to have that enabled. So this is text analytics. So this service will do the sentiment analysis for us, right? So that's what we are looking for, text analytics. And we'll go for the standard plan as such. Okay, there is a question. Oh, the answer is already in the chat. The answer is standard plan. Yes, standard is the correct one. We have five, right? So standard and then premium and then isolated. So standard is the minimum production grade plan. So so you guys know Azure as such. Okay, so the most of the services are already deployed. This is the machine learning workspace is there. So let's start with this. The other one is coming up in some time. So I'll go to my machine learning workspace. And in my machine learning workspace, I'm just saying launch studio. So this is the UI of AML service. It's pretty similar to how Kubeflow also looks, right? Like we have all the things on the left hand side, but Azure machine learning solutions are there since the very starting. I'm working on Azure since 2011 or 12 now, so since a long time. And the old machine learning studio was there since the very starting itself. I don't remember when it came out, but I remember using it in 2013 and 14 as such. the initial one, the classic studio. So it's pretty old service. So one of the initial services, and pretty good. So this is my studio. I just want to go to the compute, and I just want to make one instance here. This is my cloud workstation. Like this is my development environment. So right, that's what I'm doing right now. So this is my cloud workstation. If the name is available, no. So let's randomize it. This should be available. Yeah, no issues. Great. Uh,
Shivam,
okay. Yeah.
can you just increase the um, just zoom in? Yeah,
Okay.
people are saying is not able to see. Okay, thanks.
Right. Like this. Okay. So we don't. Let me see which region did we went for. East US. Okay. Great. So okay, no problem. So what we will do, we don't have resources in East US to run this. Okay, then thought that through earlier. So no problem. I'll just deploy the same machine learning service in Southeast Asia. We have more than 60 regions, right? So the type of account which I'm using is not exactly enterprise grade. So this is where I think I have all my previous machine learning workspaces in the same region. So it is having that 10 CPU core limit, which we can definitely increase, but not right now, not required. So what I'll do, I'll let it delete. I'll just quickly make one more. And this is machine learning service. We'll go for East Southeast Asia. Let's go to Singapore. We'll deploy it there. So I'll just change this over here. Southeast Asia, like this. And this is my Southeast Asia AML live demo over here. Didn't thought that earlier, right? So okay, let's make this here. Okay, in the meantime, we'll go back to the designing whiteboard, and we'll wait for this to come up, right? So now let's understand what is Azure Machine Learning Service. What are the various things which we are doing there? So we are understanding the middle part, right? This one, the AML service. So let's just put it here. So in the Azure Machine Learning Services, there are multiple elements as such. One thing is what you saw me create was called as compute instance. Compute instance is basically the development environment in the cloud. This is better than using than keeping your code on premise, because now you have to maintain the environments in your laptop or maybe anywhere locally. So this is where we generally prefer keeping the various Python environments as such. So this is compute instance. Let me just put that again. Instance around 4 or 8 GB RAM is what we'll go for, like this. Now apart from that, we will also be creating one compute cluster now, right? Compute cluster is the location where you train your models, right? This is the part. Can you elaborate on the web app? Okay, we'll go back to web app in some time. So this is the compute cluster. First check this out, right? So this is the compute cluster. So whenever we deploy, whenever we run the whenever we train the machine learning model, we train it on the compute cluster. So compute cluster. Now these compute clusters are of CPU and GPU both type. So generally, if you are training anything in deep learning, go for GPU clusters. They will be on the higher end, but things will run way faster than the CPU ones, and so on and so forth. So you can specify the min max size over there. So the compute instance is where we develop here, and the submit of the run will be a remote run in the compute instance. Now the data will be in data sets. So we have two options in Azure Machine Learning as such: data store and data set. So data store and data set, like that. So we in during the lab, during the demonstration as such, or during when you will do the tutorial, is when you will be using the default data store which is there. So whenever you create machine learning service, one default data store comes up, and guess what it is? This is basically storage account. So storage account. So if a data scientist wants to get the access of the data, The data engineers can put the data in the storage account and they can read from it. It's not the only location from where we can get the data, but one of the default locations from where we can get the data, and we will use that, right? You can also have other options as such. Now data store means like really where the data exists, right? Data set means like we have two type of data sets. We have tabular data set, we have file data set. If you finally want to load your data in pandas data frame, go for tabular data set. If you are working with some sort of images, pictures, multiple files as such, go for tabular data set. So sorry, go for file data set, the other one. So tabular data set is the one where we have to load it into pandas data frame in the end. uh, Something in this manner, imagine, like this. But what happens if I have multiple files over there? So I am working with multiple files now. So this is one container. Maybe this container is called as images container, and inside this images containers we have 80,000 images now. 80,000, 90,000, any number of images as such over there, like this. So now I cannot specify one file as such because I have uh, thousands of images over there. So what do? We provide the exact the file path, and then recursively we load the data from there, and then we work with it. So this, right, so this becomes a file data set, like that. Now data sets are just metadata. Don't think that we have data over there. This is only metadata. Data will be in data stores only, right? This is metadata. So tabular and file. So whenever required, we'll create tabular data set. Whenever required, we'll create file data set, and we will work with it. Now there are some questions in the chat. Can I also uh, load into pandas data set using file data set using glob as such? Pandas data set, pandas data frame basically, and using the file data set. Now that question is a sort of certification oriented question. The answer is this will happen. See, check this out. I'll just answer that quickly, and it's something which you will realize it soon. So imagine I have two CSV files. So this is one CSV file, and this is the second CSV file, CSV1, CSV2, like this. And there is a particular structure inside that. Structure remains same. We are saying the schema is same. Schema doesn't change. So this is exactly same as that. So now what you do, you create one tabular data set using two files. Now what will happen? They both will sort of merge together. So finally this will happen, and yes, you will be able to load it further. Hopefully that's what you were asking. So this is the final outcome. They both merge together. If the schema is not same, you will get an error right away, right? Then you won't be able to load it in this manner and work with it. Okay, now check this. So we have compute instance, and let's go back. Let's create this compute instance, and the machine learning service in Southeast Asia is running. Let's go and find the compute, and I'll just close the previous tab so I don't get confused over here. This was the previous one, right? Let's okay, let's, yeah, this is the one. Uh, it's too zoomed in for me. I'll just get used to it. Give me a second. So this is my workstation in the cloud. I'll just give it some random name. I'll just zoom out, let's say, a little bit. So we are going for CPU. Default size is fine. We just want to develop the code. We don't want to run it locally. So even 14 GB RAM is okay. Uh, right. So this is where we will be. That's a development environment. Now, is there a sample data store on Azure for practice? There is a concept. Look up for there is a thing called as Azure data sets. Just Google for Azure data sets. You will find it. They have released a lot of data over there. COVID data is available. Uh, the New York taxi data set is there. So look up for that. Or deep learning image file training. I not sure what was the previous part of the question. Just put the full question again. Okay, so this is coming up. This is basically that compute instance is coming up here. That's the compute cluster. We'll be making it in some time. Now, once the model gets trained, what we will be doing is, so this is where the model training will happen. And so let's say the model get trained over this, right? So as a normal process, we register the model. So why do we register the model? Because any company will be creating hundreds of models. A lot of them will not even go into production, will never see production as such. A lot of versions will be there. You will do hyperparameter tuning. You will find uh, that maybe this model was better than that one. You tried different algorithm. You tried another set of learning rates. You tried another set of regularization parameters, and things changed. So you may have multiple versions of your own model. So what do? We register that. Now the registry is already available in the AML service called as model registry. So model registry over there. Now in the model registry, we will be registering the model, or we will be saving the model, or anything like that can be said. So this is the machine learning model, let's say version 1. Maybe tomorrow we'll have version 2, and so on and so forth. So all the versions are there like this, right? Let me go back and see if it is ready. Okay, it will take some more time. So let's get back. Now once the model has been trained, we come to the part where we go, uh, there is something in the chat. We cannot see the left part of the screen because of the banner. Okay, so I'll do, I'll just quickly put it like this. Right now you can see the screen. Okay, now focus it over here. So what we are doing is, this model which is already there, we will containerize that. So this is the Docker image which will come up. Now the good thing with Azure Machine Learning SDK is that this containerization process is not manual. We don't have to manually sort of, you can say, write the Docker file. We don't have to manually specify the Docker compose or maybe anything to create the Docker image over there. They have abstracted lot of the details from the data scientist using the SDK. So the Docker image which we are using, so we'll create one Docker image today, and it's a very straightforward process when we use the AML SDK. So the model so this is the machine learning model, the trained classifier, right? Uh, let's say some version of it. Dependencies will be there, and some files will be there. So here some score files will be there. Score file. I'll explain what is score file in some time. Score.py, like that. Let me see if the compute instance is ready. In the meantime, let me just look up for that GitHub link. I saved it somewhere in my secondary screen. I'll just quickly look for it. Okay. So this is okay. That's the Jupyter notebook, and I just want to git clone some of the files as such. Now anything which I am doing is already there uh, as part of the link which was shared by from the reactors handle few minutes back. So you can go up in the chat window and you can have a look at it. So whatever I'm doing is already there, given to everyone. You can, whenever you guys get time, try it out. So we are git cloning one repository, and basically there are few Jupyter notebooks available on the repository which we want to get from there. So let's let it finish that. Oh, great. So okay, so I just need few of them. As I was saying that I will run the code first, because the problem is it will take time. Some of them will take 15 minutes to run. So in the meantime, we'll discuss the code over there. How to create Docker image and Kubernetes orchestration for a Python web app using Azure. Any training video link or demo? This is not the right session for that. Look up in the documentation. Look up for AKS documentation in Azure's own documentation, right? Just look up in the search browser. They have an amazing 7-step documentation of it, and they explain how to make the Docker file. Now check this out. So we have we are installing few of the libraries. So let's just run that. So we are installing basically NumPy to open the Excel files. We have few libraries: Pandas, Scikit-learn, TensorFlow, JobLib, NLTK will be there, GenSim will be there. Open Neural Network Exchange is what we are installing. Keras to ONX, ONX runtime, and TensorFlow to ONX. What do we do with it? I'll explain in as we come to it. Right? We'll see it what they are doing. So let them install for the point in time. We'll be back to this page in few minutes, and okay, great. So in the meantime, let's see this. So this is where we have the Docker image. So one of the step which we'll be doing is that we will be creating this Docker image, and this Docker image will be having the trained machine learning model. One code file will be there, and dependencies will be there apart from that. Now, the in Azure, we have multiple locations where we can deploy the Docker images. Uh, One of them is Azure Kubernetes Services. We can also deploy them in Azure container instances. So this is where I'll just put two arrows right now. Let's say this goes into AKS, Azure Kubernetes Services. I think last week you had a very amazing session on AKS. You can have a look at the session from the last week as such, which was on AKS, right? Just go and have a look at that. Now, the today what we are using is ACI, Azure Container Instances. So Azure Container Instances are those locations where you can also deploy the ML model. So this is what we are using today. So right over here. So if I just go back to my previous diagram, please have a look at this. So you see this, like there was supposed to be a computer vision and text classifier over here. This text classifier which we have to create, this particular model needs to be deployed somewhere, right? So this green box which I'm creating is is the Azure Container Instances, ACI, over here. We'll give it some GB RAM and few, you can say, some CPU cores, and this is where the API endpoint will open, and the API calls will happen to that particular uh, model. We'll do the scoring with it, right? That's one of the plan. Now there is one more thing which we are doing. The Contoso insurance company, in one of their requirements, are also saying, or they are also asking as part of one of the objections, is it possible that we can deploy uh, in Azure container instances? I don't have a machine learning model, but I want to do some pre-processing on data. Can we do that? Right? So is it possible to do pre-processing only uh, over the API calls, not the inferencing as such? Is this possible? Answer is yeah, we will do it. So one ACI will be there hosting the text classifier which we will create. We will have another ACI as such where we are putting the which I'll just put it here. We are doing pre-processing on the text. Now, in the meantime, can someone help me out? When you do pre-processing on text data, what are the high-level points as such? Like, what do you do on the data? Like, what steps are there as such in text classifiers? Then just give me a few of the names as such. Like, what do we do as part of pre-processing of text? In the meantime, I'll just make some boxes here. So right, so in this ACI we will do pre-processing. Tokenization is, someone is saying tokenization, perfect. What else? Sorry, I was just adjusting my screen. Yeah, okay. Tokenization, stop words removing. Lemmatization uh, is removing stop words. Okay. We have verbs, remove all the verbs. Okay. And lemmas, token, stop word removal. Okay, what's the difference between? Help me out, someone, please. What's the difference between lemmatization and stemming in easy words that everyone can understand, right? So, in easy words. In the meantime, I'll just run the files. I want to just go and have a look at are they executed or not. Yeah, some few warnings are there, but I think it's fine. Okay, great. So we'll go through this code, but we'll run it first because it will take some time. Uh, what is the difference between lemmatization and stemming in the meantime? Yeah, this one takes 15 minutes. That's what I want to run right now. This one. This will take time. So let me see it is running, then I'll start explaining it in few seconds. I'll tell you what we are doing. Just want to run it. Right. Let me see if I have to enter any value anywhere. Uh, yeah, this step, it's gonna take time. And the okay, let it run. Let's see. I am not sure if this name is unique enough or not. Hopefully this name will be unique enough. Otherwise, we may have to run this again. So we'll see. Okay. So let me read your answers. So lemmas is removing commas and semicolons only. Okay. Stem is will not give a proper word. Okay. Someone is answering that stemming is to remove ings and eds. Removing eds, ings is stemming. Okay. Then what is lemmatization? It doesn't remove eds or ings. Uh, or will it remove it? Will lemmatization remove the eds and ings or not? That's the question. Yeah, that's a very to the point answer. Stemming is just removing suffix without looking for the root word. Accurate. Uh, uh, it's the other way around. Lemmatization, lemmas are the root words. Stemming is that brute force one. The other way around. Yeah, lemmatization is the context based. Like, so what lemmatization does is it will convert your words into in proper dictionary words. Like the root words will be there, but they will be having dictionary meanings. Proper words will be there. Lemmatization is little more expensive computationally. More expensive, not little bit, but more expensive computationally. Stemming is the brute force one. It just removes the eds, ings. Doesn't matter what happens. Just removes everything as such. Uh, right. So there's a difference. Now, okay, so what we have to do is we are planning of deploying, we are creating one ACI, and inside that ACI we are planning of deploying the pre-processing service. So here we will be having the pre-processor of the on the text data, and they will be some dependencies will be there in this. And whenever we do the API call, over the API call we have to give the text, and it will do the pre-processing and we'll get the output, the pre-processed text. That pre-processed text is what we are using in the upcoming steps, right? This is one of the initial thing which we have to do as such, right? Now let's go back and see that. Okay, so now I'll do, I'll take you back to my slide deck. I have a I think I have this in the slide deck there. I'll just go back to my slide deck. I just want to show you something over there from the point of view of pre-processing of text. Now notice this. So what we are doing, so if you think about text classification, the common scenarios which we have is that documents are having some labels as such, and you have documents. So right now I have the quick fox, the lazy dog, the rabbit hare, and so on and so forth. Now, as part of the text pre-processing, uh, there are multiple things which are there. We can definitely do tokenization. We have to do it. Parts of speech tagging is also like verbs, any nouns which are nouns, and so on and so forth. So that particular tagging is also part of it. The phrase chunking, like you tag and the phrases as such. Now stemming, the brute force one, removes all the eds, ings, and so on and so forth. The stemming also, right, the stemmer is there, and the lemmatization is there. Lemmatization will convert the word into the root form of the word, which is having the dictionary meaning, meaning it's a proper word. Stemming doesn't guarantee that, right? It will convert into the in some sort of root form, but may not guarantee the correct dictionary meaning. It may, your the words from which you have removed the ing, it may become something else. So caring may become car if you do that, right? You remove the ing. Spell check, convert everything into lowercase. Why do we convert everything to lowercase? We don't want, anyways we have so much of dimensions, we don't want to further, we want to reduce the number of dimensions, such as we want to reduce the number of tokens which we want to work with. So convert everything into lowercase, so capital and lower will convert back into one as such. Remove the stop words. Now stop words will are for beautification of the language. You Apart from any word which is having a sort of negative meaning, for example, I do not want the I don't like this service, I do not want to get the insurance, I so that not which is there is pretty important, because it sets the context whether the customer wants it or not, right? But I so apart from that, and dot, they, any stop words like that, we remove that, because they will just beautify the entire text, will not help us in out in the from the machine learning's point of view. We expand the contractions as such, like if you have any can't, it becomes cannot, and so on and so forth, right? We expand that. So all the once we have pre-processed the text, we'll do the feature extraction, we'll create the vocabulary from it, we will vectorize. Now machine learning needs the vectors as such. We want to represent the text in some numeric format, so that numeric format will be that vectors which we are planning of creating. Now there are multiple methods of creating the vectors. One of the easiest one will be, for example, one hot encoding, right? Just put 0 1 0 1 as such, one wherever you have the particular character or word coming. Now we also have TF-IDF. TF-IDF is the one which gives the importance to the rare words, right? Like if you have a lot of documents with you, and in those documents some rare words are there, so the words which are rare are more important than the more common words. So that is TF-IDF. And we also have global vector representation. So globe is what we are planning of using today, as such. So whatever labels you have, documents as such, we will create few, we'll convert the data. So for example, if you see the quick fox lazy dog rabbit hair, quick fox lazy dog rabbit hair, and there are some uh, you can say numeric quantification done to that, and we have created few vectors as such. So on a high level we will be creating the classifier, and that classifier will further be used to do the classification. So over here, right, like this. So the very first thing which we need to do is we need the data to be pre-processed. Now this part is what we are deploying as a web service in ACI over here. So we'll have one solution running in ACI, to which when we give the input data, it gives me pre-processed output, right? That I can further use in my rest of the machine learning process. Okay, there is one question in the chat saying how to solve missed spellings or incorrect word placement or slangs as such. Now, the spellings which are not proper, we have pre-built AI solution for that. Like there are both options are available. We can have custom AI as well, or we have pre-built AI as well. Like spell checkers are there. They will be able to handle most of the you can say missed spellings or wrong spellings as such. We also have the grammatical correction services which can correct the grammar. uh, these slangs, that is something which is specific. Slangs may or may not be caught, because different vocabulary, different languages, different you can say even in the same country you may have so many dialects and they have so many slangs. That is something which you may have to further handle as part of your uh, right, that you just have to handle as part of your uh, the when you handle these slangs. Apart from that, rest we can handle. We have cognitive services and we can have libraries also to do that. Okay, now let's go back to what we were deploying earlier. I'll just take you back to it. Okay, let me just see, is it going on, or yeah, it will go on for a long time. Okay, let's have a walkthrough of what we are doing. So so first we are doing the summarization of the text. So the thought process is that we test it out locally, we summarize the text, we understand how it works, and then we will deploy it as this web service. So then the deployment happens in this blue color ACI, right? Now so there are multiple things, like we have to for example we have to uh, the line breaks are removed, the stop words are removed, the paragraphs are broken into sentences as such, and then we use that. So this is first we are doing the normalization of the text, we are removing the line breaks, we are doing the tokenization of the paragraph of two into individual or you can say into sentences, and then we remove any extra spaces which are there, like if you have given extra spaces, then that part will be removed. So this is where we are using NLTK already contains these sub and the strip functions as such, which will help us in removing the line breaks, which will help us in removing the entire you can say the break the data into multiple sentences. Now once we have done that, we are sort of the if you remember, contoso insurance was asking for summarization, that if there is a very big document, summarize it. We want, so the agent who is doing the processing will can get the gist of it, like they just go and have a gist of it. So there is a particular function called as summarize, like this. It is already available as part of the gensim library as such, which is over here, this one, summarize. So what it does, there are two concepts which you have to know to be able to understand that. There is a concept called as text rank and there is a concept called as page rank. So page rank is for example, if I summarize that, page rank means uh, depending on the links which are going into your page or depending on the links which are going out of your page, there is a ranking done of your page as such. How important is your page on the webs on the search engine? So that is something which Google does whenever you upload any blog or website and so on and so forth. So there is a page rank. The text rank basically means that uh, if I have, let's say, word 1 and word 2, so if the words are following each other, let's say the second word always comes after the first word. So based on the frequency of how many times they are getting repeated, there is a rank given to it. How important are these words? So to summarize the data, there is a function called as summarize. What this summarize does, it finds that text rank and the page, and based on the text rank, it summarizes the entire paragraph. So if I just show you this example document which I have over here, I was driving the car, I stopped at a red light. It was 3 p.m. in the afternoon. The sun was bright, shining just behind the stop light. This made it hard to see the lights. There was a car on my left in the left turn lane. A few moments later, the another car, a black sedan, pulled up behind me. Then the left car changed. The left turn light changed green. The black car hit me, thinking that the light has changed for us, but not, it has not moved because the light was still red. The person is pretty descriptive, right? Like uh, they are describing each and every second of what happened over there. So okay, so after hitting my car, the black sedan basically backed up and then sped past me. I did manage to get the license plate. The license number is ABC123. So this is the input text. only one example of it, right? It may be even bigger than that. Like when you are claiming the insurance, you may would like to explain that you are not the guilty one, uh, and right, and there is something which happened and you're describing it. So we have to summarize this. So the way we are doing is that we are using that particular summarize function, and if we give the summarize function as part of it, what it does, it finds the most important words from it, most important uh, pair of words from it, and the summarization which is done is something like this. Like when the left turned light changed green, the black car basically thinking that the light has changed for us, but the light was still red, and the license plate is ABC123. So that's the part of summarization which has been done on the text. So this is something which is very interesting asset. Like if you have any legal documents and you are looking, being a lawyer, so let's say you work in a maybe let's say you have to deploy the solution for any of law firm over there. So there's so much of there are so many court verdicts which come, you can say, every day, that for anyone to keep a track of it or anyone to do research into it will be very difficult. So if you are the one who wants to keep yourself updated, you may like to read through the summary of it. So this type of service is very useful for various industries to summarize what's going on, right? So okay, so now what we want to do is, this is what we also want to deploy as a web service which we can use further on. So if I just go to my second uh, notebook which is still running, we'll just go through it. So first of all, we connect the service to the Azure Machine Learning workspace. Now, this is where these are just boilerplate code. It always remains sort of same. Now, if you see, we are just doing a from the config file, we are importing the workspace. So workspace is the one which I have deployed here. Like this is my workspace. Now, because I have redirected from inside the workspace, I don't have to download the config file and put it over there. Otherwise, there was one more extra step of downloading the config file from this page, from here, and uploading it in the root directory over there, or maybe give the path of it. So that was one more extra step if we don't redirect from the same location. Meaning I can use Azure Machine Learning Workspace from anywhere. I just need the config file and the SDK to be installed. Now, what we are doing is we want to deploy the model in ACI. Now, whenever you work with ACI, there is a particular file called as a score file which is required. So the meaning of score file is that, if I just take you back to the diagram where I was putting it earlier, so over here, so what this score file does, this score file will have minimum of two functions. There will be one initialization function will be there, and the second run function will be there as such. Like these two functions are there in the score file. This same you can say similar score file will also be there in this diagram. Like you can say that let's say that this is the score file over here, right? uh, in this manner. So there are two things which we are looking for: initialization and run. So let's go back and have a look at that. So if you see, this is the initialization over there, and that's the run. So what initialization does, it basically if you have to describe it to somebody, initialization basically sort of initializes the model as such. Like it loads the model into RAM. For example, if this was having any machine learning model over there, we would have said model.load over there, and it would have been loaded in as such from the saved file. What run does the heavy loading. Run is the one which does the model.predict. The prediction happens in the run function. So right now what we are saying is that whenever, so the entire code which we had when we were testing the data, when we were testing the summarization locally, is what we have put as functions over there. So we have the clean and parser function as such. We have one summarized text. We will be doing the same entire step. We'll be doing the tokenization. We will clean up the data. We'll remove the stop words. We'll remove the spaces as such. And then we have, and this file is what we are writing locally. We are not running it anywhere. This is the magic function. It locally writes the file. Now, once this score.py is there, which right now is named as summarize underscore service.py, but the generic word is score file, like the type of score file which we have. Now, what we are doing, this particular score file is supposed to be inside that ACI. So we have to create that object where will specify that. We'll say that, okay, this is your score file. That's what you have to do. You have to run here. So now we have to uh, make that ACI instance. Now, before we do that, uh, we need dependencies. Like, you have to define dependencies. In Azure, there are two methods by which you can do it. First is there are ready-made environments available. So if we were using something which is more popular, maybe we are using TensorFlow, maybe we are using some PyTorch version, and so on and so forth. So we have ready-made environments like TensorFlow, and some dependencies, scikit-learn environments. So scikit-learn with the dependencies as such. Uh, we will have PyTorch environments, right? We call them curated environments, like ready-made, already existing environment. So I don't have to uh, create things from scratch. I can simply use the existing environments over there to whenever I create the container uh, over there. Second thing is, what happens if we want to custom define it? Totally possible. So you can custom define it. So you basically, now there are two options. You can write the Docker file as well. So the Docker file is that .yaml file will be here. Uh, and in this Docker file, we can specify what details are there. The second option is you can define it inline. So there are two ways, right? You can also define the dependencies inline, or you can have the Docker file. You can you are saying that I just want to do it once. So using the Docker file, maybe the inline mechanism, you can have the dependencies as such. Secondly, if you are doing any repeated task, it's better you save it, sort of, right? So what, with these Docker files, with the inline dependencies, we can also create the environments, the custom environments, and with those environments later on we can pull that. So maybe we or our colleagues will be able to pull those dependencies, and whenever the deployments are going on, that one step can be abstracted now. So this is what we are doing. We are defining the dependencies inline, and then let me just show you what do we mean by that. So right, so we have this environment called as my environment. That's the name as such. So the environment name is my environment here. So my environment, like this, and right, like that. And we are doing conda dependencies as such. You can also do pip based dependency installation. Whatever you're doing, pick up any one of them. Either do conda install, or maybe you do pip install. Pick up any one of them. It's a good practice. You can do use both as well if you have to. So we are basically going for NLTK. We are saying that gensim 3.8.3 and NLTK 3.4.5 and so on and so forth, that is supposed to be there in the environment, and this will be registered as my environment over there. So what happens when you run this code, right? It basically, if I just expand this, you see this environment which is in preview right now. If I click on custom environment, you see that my environment. So it got registered there. Now tomorrow I don't have to define. If I'm doing some repeated task, I can pre-create my environments. It reduces the time. The best thing which I personally like to do is, like, when you create the environments, there are two options. Like, you can also say docker true. So you say docker true. If I say docker true, then what happens? This is basically a docker image, right? So this is where uh, this will be a docker image over here. So now the time which goes into installing the dependencies will not be there. So you have the golden docker images, uh, pull them, and uh, deploy your score files inside it and start working with that. So that is also possible. We can suggest this to Contoso. That Contoso, please, you can try that out. This is my environment got registered, and right. Let me just read few of the questions in the meantime. Okay, what measures should we consider to minimize the charges while designing the solution? So the costing, there are multiple type of costing in Azure. Like, for example, you have like compute is pretty expensive. Like, it doesn't matter Azure. It like any cloud. storage is cheaper, compute is expensive. So try to use serverless solutions. Where, so someone was asking few minutes back, sorry I forgot that what is serverless. Now in serverless there is compute on demand. If you don't use it, you don't pay for it. uh, like you can, so in Azure we have Azure functions which are serverless. We have SQL database which is serverless. So there is a database which is serverless. Like there is a storage cost, but the compute cost is on demand. If you use 3.6 GB RAM, then you only pay for 3.6 GB RAM. You don't have to allocate 4 GB RAM. Pre-allocate like that. It goes up and down between the min max. So serverless gives that on demand things, brings the cost down. Not and you really have to design it properly. If you have some repeated task and you create it serverless, then it doesn't make sense. Like if you have long running tasks, sorry, then if you make it serverless, then it may not make sense to you. Like then serverless is something which, like, short running tasks are there where which creates burst out, die after some time. So second cost will be like, go for the this is where HDFS versus, let's say we are going for ADLS versus storage account. ADLS will be 10 times or more, 5 to 10 times more expensive than storage accounts. So if you really want that throughput, high throughput, if you really want your data bricks to read from that DFS location from using that ABFS driver, not the WASB driver, if you are looking for that parallel write and parallel, you can say, read as such, then you go for the expensive solutions. Otherwise you can minimize cost in multiple tiers. We have SKUs available. We have premium SKUs with SSDA backend. We have non-premium SKUs with HDD backends as such. So storage, try to minimize the compute. That's one thing which comes to my mind. Secondly, use things which are serverless, something which you don't have to pay when they are not running. uh, and make sure that the traffic goes in, don't don't come doesn't comes out much, right? Because that's where also a little cost comes into picture. Serverless less possible only for development or in production. Also serverless is totally possible in production. We there is nothing like not possible in production. It's production grade. And right. So okay, in the meantime, if you have more questions, feel free to ask. Okay, check this out. So we have the environment with us, and we have registered the environment. And I just want to show you a few of the main parts. So we are saying that ACI.deploy configuration, pick up the summarized .py file, use the my environment, CPU core is 1 GB RAM, put some tags and so on and so forth. So what is this CPU core 1 and so on and so forth? This ACI which is coming up here, this will get that one CPU core, this will get that 1 GB of RAM. Give it more if you require, right? So but this is where that part is coming up like this. And summarize.py is this file over here, the main file which is doing the pre-processing of text and the summarization for us right now. So we define it something like that. Now so this, even when you will reproduce this particular scenario, the step where we create the ACI takes more than 10 minutes. So that's why we were waiting on this particular step. Now if you notice, we have it's already deployed right now. So if I show you like where is it deployed, if I take you to my resource group over here, it should be somewhere in this. So if we just zoom in here, we should be having one container instance running there, this one, called as summarizer like that. And this is where the container is running, this one. So what is the summarizer doing? This is the one to which we, if we do the API call, will pre-process the data, give the summary out as such. So if I take you back, we are testing it out, like does it even work or not. So we have the same example document. The we do the web service dot run, and this is the scoring UI URL. So this is live right now, and we'll just open one notepad, we'll store it. uh, we need it in few minutes. Let's say notebook number 2 output. Right. Okay. Now so check this out. Now apart from this, this is where the pre-processing part was done. So now let's move to the LSTM part, right, where we have those RNN machine learning models where the text summarization will be done. So the customer is also saying that if somebody puts the supporting text to the claim, is it home insurance claim or is it auto insurance claim? What is it? So that is what we have to create and deploy. Now what I'll do, I'll just go back to the notepad. I'll run it first because it's gonna take a long time to run, and because a deep neural network is getting trained right now. Let me just have a look at it. Uh, yeah, looks great. So let me run this. It's gonna take around 15 minutes to run. In the meantime, I'll explain that DNN which we are creating. So okay, so 15 minutes for this and then 15 minutes for deploying that. In the meantime, we'll discuss few concepts, right? And okay, now check this. So we so whenever you are, so here we are creating the deep neural network, and that deep neural network is supposed to process text as such, right? So we are thinking of creating one LSTM, basically, so it can long short, you can say long short term memory recurrent neural network, and so it can do the text uh, classification for us. Now help me out. Uh, is this a, so basically what do you think, like, is this part of supervised learning problem statement? Is it unsupervised learning problem statement? What comes to mind, like what type of problem statement do we have? uh, what do we have to do with this? Like when you create the machine learning model, uh, do you have labeled data or do you have non-labeled data? Like what is it labeled or unlabeled as such? Supervised, unsupervised, what do you think we have to do? Okay, so we have AK saying supervised machine learning is what we want to do. And what is this LSTM, guys? Like, what is it? Like, what's the purpose of LSTM? How do we use it? Any thoughts into it? Um, Classification is supervised. Yeah. What are the technologies supported by Azure functions? I think you're saying the programming languages, right? Use Python. You can also use uh, C sharp. Use PowerShell. Use Golang, uh, and so on and so forth. Node.js. So anything as such. Functions are pretty cool, right? Now, what we are doing is we are creating this deep neural network, and we will be creating that LSTM. We have basically two type of labels with us. One is auto insurance claim, and zero is the home insurance claim. So the on a very high level, if I just put that part first, I'm pretty sure you guys are experts in machine learning. But basically, what we are planning is that the data which we have, right? So this is the data set, and it is text, right, like this, right? So we have some text, and then labels are there, 0101s. So this is 01s, like this. So this is your target attribute, and these are the basically the independent attributes as such, the features which we have, right? Let's say this one, like this. Now, because we are working with the text, we have to pre-process the text first. You have to convert the text into some sort of numeric representation, right? So first we have to sort of encode it. We have to embed it. We have to look for some method by which we can do that. So once we have the data, once we have that text which is now encoded. So let's say this is the encoded text. So text got encoded into some numeric representation. Now on top of this numeric representation, we will break this data. Let's say you have few ratios as such. Maybe you are breaking into 70-30%, maybe you have 80-20%, or any other ratio as well, which comes to your mind. Or maybe you are using basically you are saying no, we are looking for cross validation, right? You may have k-fold cross validation done on top of it, anything which is there. But basically we are breaking this data. We have this training data set uh, over here, and then we will be training one machine learning model like this. And with, so this is a training data set, and with the 30% of the data we'll be doing the testing on the data set. This part here, we do the testing of as such, like this. So there are two phases which we have to perform. Like we have to first train it, then test it out, and afterwards deploy in production if it is performing well, if the accuracy is high enough, if it is classifying it properly. If we have apart from accuracy, someone help me out, uh, which other matrices are there in classification? What are the evaluation matrices which we use in classification? Can you, apart from accuracy, if you can name few as such, and which one do you guys use? Like, how do you do it? Confusion matrices, okay. Precision, recall, any other? Precision, recall, accuracy, sensitivity, specificity as such. False positives, false negatives, okay. So false positives, false negatives will be, okay. AUC under the ROC curve is also pretty popular. What is the range of AUC under the ROC curve? Like the area under the curve of ROC. What's the range of it? Which model is a very good model? Which one is a average type of random classifier or something? What's the range of it? Okay, let me in the meantime let me check, is the model trained or is it still going on? Okay, no problem. So I'll make one compute in cluster in the meantime. I'll just remove the previous one. Let's see. Or otherwise, we'll create one with the same name. So, okay, 0.5 is random classifier. 1 is good, right? Okay, towards 1. Towards 1 will be good classifier. As close as 1. If you're really getting 1, then it might be overfitting, right? So, that's not going to happen. Yeah, okay. Compute clusters are deleted. Let me see. Let me run it one more time. Let's see. Yeah, okay, great. Yeah. Now we have to sort of wait for it little more. I should have noticed that earlier. The Because we changed the location. So see now, in whenever you work with Azure, in we so for example, there is one question which a customer always asks, like, is every Azure region having all the Azure services? Answer is yeah, nearly. But the SKUs may differ a lot. Like the SKU which is available in US region may not be there in Southeast Asia. So when the SKU was not there, so now we are creating another compute instance in Southeast Asia with another SKU. So that is running, uh, and will take some time. In the meantime, let's hit this LSTM. So what we are doing, this is where we are using LSTM, and this LSTM will get trained, and then this LSTM is what we will, you can say the trained model is what we will register, right? And once we have done the registration, so this is Azure Machine Learning Service, and in the Azure Machine Learning Service, if I take you back to my landing page, you see these options, models over here. So this is somewhere you will see after registration, it will come here, right? That's where we will see it. Now, what we will do is, after registration, we'll do the containerization, we'll deploy it, right? And we will see what to do with it. Now, the if you talk about LSTM, this is where the deep neural network comes into picture. Now, neural networks are inspired by human brains as such. We have neurons in machine learning. We create artificial neurons, and the inspiration is as similar as the human brain, the way human brain, or what the scientists think human brain works like, is how the neural networks are inspired. Now we are using one thing called as LSTM. The reason we are using it is because we are working with text data. So I have one example which I took from, you can say, from internet only. Let me just put it here. It's pretty interesting. Let me see, and it's one of the, let me see. Oh, I really have to. So let's say you were working with the text data, and there was two things, like let's say due to the current um, job situation. Let's say due to the current job situation, uh, I complete the statement, right? Like that. Versus, let's say there is another statement which is like this, right? So here it is written today due to the current job situation, I, right? The second statement is, let's say last year, like that. Last year, due to the current job situation, due to my current job situation, let me convert this to my last year, due to my current job situation, or my job situation maybe, right? Little bit of changes we can do. We have to complete the statements. There are two different statements. First statement. Now, if you notice this statement pretty closely, I'll just try to fill some, I'll try to fill it up. I'll say that I need to take a loan. I need to take a loan over here. And this one is, I had to take a loan. I had to take a loan. So if you are creating that machine learning model which is supposed to complete these statements, the most important words will be the starting ones, like today and last year. because because of that, today and last year, the entire context is changing. When the machine learning model completes this statement, looking, oh, I think the screen is not totally visible, so I'll just put it somewhere here. See, now it will be visible. So I have these two statements with me, today and last year, like this. So based on today and this part last year, the entire context is going to change. So when the model completes the statement, the output changes, right? So the important thing is, the machine learning model which we are creating should be able to remember. It should, so see, just like human beings, just like you guys, you have short term memory and you have long term memory. So short term memory will be something which is used to uh, keep something which you did today, maybe last, which what breakfast did you had in the morning, right? Did you even had anything or not? What did you do maybe yesterday night? What was yesterday's breakfast, and so on and so forth. Something will be in short term memory, like you will be able to recall, I did this, somebody spoke, so some, you were on a telephone conversation and you were having it with someone, and whatever they have said is there in the short term memory. The second thing is a long term memory. Long term memory will have more data, where you will be having some sort of you can say uh, the skills, maybe you driving the car, maybe walking as such, speaking, maybe you know a few languages over there. So you will have some long-term memory as well. So short-term memory and long-term memory, like that. Now, what the way I want to explain, of the way I want you to understand, is that we because this is something in a very big statement. Let's say the statement is pretty big, the context is pretty big, the utterance is pretty big. On that, whatever these words which are there, which may be part of the long term memory, makes a huge difference. They will, having the context of that, using the context of that, the end output will be totally different. So this is where LSTM comes into picture. LSTM is the one which stores that information in the long term memory. So if I just go back and give you a little brief about LSTM, see, LSTM is a very sort of big topic, but we still will be able to understand what it does, right? The mathematics behind it is something which you can look up in the documentations, but have a look at this. So what this will be having is, we are saying that there is a memory cell now. So in LSTM, we have this memory cell right over here. So let's say like this. Now in this memory cell, we have to maintain short-term memory and we have to maintain the long-term memory, right? LSTM, like that. So let's put few colors now. So let's say this is the long-term memory, long-term, and then we have short-term also. So this blue one is the short-term, short-term. Now, if something is not relevant, if something is not relevant, remove it from the long-term memory. If something is not relevant, remove it from the long-term memory. During the training phase, what is relevant, what is not relevant, using the supervised data which we have, will be learned by the LSTM network and will be stored in the long-term memories. So if we go in slightly more depth, how can we expand that? Like, this is long-term and short-term memory, but if we just expand it a little more, it becomes something like this, right? So I'll make a bigger box now. And if you already know LSTM, you know what I'm going to specify. If not, have a look at it. So imagine this is that same memory cell, this time slightly bigger. I'll make sure the top part of the banner doesn't blocks the page as such. So this is that long-term state of the cell. This is the short-term. Let's put it here, or the hidden state. Let me put it like this. So in the LSTM units, what happens? There are few gates over there. The concept will remain same, right? If something is not relevant, remove it from the long-term memory as such, or sort of forget it. Now I'll just put some data over there. So this was the previous state. So previous cell state was coming from there, right? Previous one. Now this will go in the next one, next unit. Here I have, let's say, hidden state t minus 1. The previous one, the output of the previous one. This is the output of the current one. Let's say we have ht over here, like this. Now there is some input now. So let's say this is the input which is going in. So as the input, we are saying this is input. So if we just go back to the statement, we'll pick up one word from it. So input right now is, let me find where is that notepad. So imagine we are saying that the input is the job, like that. So job is the correct input, current input, job, xt, like that. So now inside LSTM, what happens? There is a concept called as forget gate. So there is a forget gate over here. Let's say forget gate, something like this. Now the previous hidden state which is there, that hidden state. So I'll take some, maybe I'll just wipe it off a little bit. I'll try to make it as clean as possible. So let's say this one, and some biases will be there, some weights are there, but finally the output of whatever you're inputting, that part, these two. So here we'll have one activation function on top of it. So this activation function is, let's say, sigmoid over here. So this is a sigmoid function. Now if the easier sense is, if something is not relevant, forget the previous value, right? Or make it near to zero, make it as small as possible. So forget it. Now let's say you forgot something and now the value is more important. The job is supposed to be there in the long term memory. So now what we have to do, we have to input this new value. So this the same the hidden state, and then we have two activation functions over here. So I'll just make two circles here. One is going to be sigmoid. Let me put sigmoid, and this is tanh. So like this, and let me take the input from here. This is the input is going. Weights will be there, some biases will be there, and so on and so forth. But finally, what happens? There will be one input gate. So some like the output from here will go into this, let's say input gate like that, and this will be adding to the memory. So this gets added to the memory. So I'll just say that we are adding it to the cell memory here. Add to the memory like this. Now so the LSTM unit is now remembering the old value, right? Now so this is basically, there is one forget gate and we have this input gate. These two things are there in the unit. Now there is one more concept. Now whatever has been, so see, there will be multiple units, like this is one cell, then another cell will be there, and so on and so forth after that. So what do we do? the the same input, let's make that blue line one more time. So it's going in something like this, and let's make that red line one more time. So what you will notice is that we have another sigmoid function there. So this is the sigmoid one, another third time sigmoid. And now what will happen? The output of this and whatever that value was there, and then there is another activation function, let's say tanh. So this is the, let me try to put it some, it's slightly complicated, but the concept is pretty straight away. If something is relevant, keep it in the long term memory. If not relevant, just let's not put it there. So let me put it in this manner. So there is one output gate. So output gate over here like this. So in this manner, and then the output is going out. So this blue line is what we'll create a little bit on the top like this. So this is that HT over here. Now, this is basically the structure of one LSTM unit which we have. So what it does, when text will be inputted into in this LSTM neural network, the the long term memory will be used to store the, you can say, the data which is more relevant to be able to complete these statements, or to be able to find that uh, you can say find the entity tags, or to be able to find the next values. If not relevant, the forget gate will be there, it will forget the value. Now this same concept is what we are using in the code. So if I take you back to my code, you will notice, if I just take you back, so what we have done, we have one second, let me just run it in the meantime. Okay, so what we are doing, I'll just take you back to the main part first. So have a look at this. So using Keras, we are creating one sequential model. Now Keras is part of TensorFlow. Earlier Keras was separate and now TensorFlow was separate. Now they have sort of merged, absorbed it as part of it. So we are creating one sequential model. There will be one embedding layer, because we are working with text data. We have to first encode the data into a manner which mathematics or which machine learning algorithms can understand. Then we are putting that LSTM layer with 100 units, and there is a dropout of two, you can say 20% as such, or there is a recurrent dropout of 20%. There is a dropout and there is a recurrent dropout, two different concepts we'll see. And then we are adding one dense layer. There are two neurons into it, and the activation function is sigmoid. So if I just try to create this in a diagram, how will it be looking like? Will be something like this. So if I just put that part, you will notice that we have the input. Oh, let me just go back and see. Oh, embedding layer was there. So the input data. So this is the input data, like that. This input data goes in the embedding layer. This embedding does the the embedding as such converts the text into some vector representation of it, right? Some vector representation. So this part, uh, like this. So uh, let me put it here. So apart from this embedding layer, we have LSTM after that. Let me make it in this manner. So uh, let's put it like this. This is representing one of the unit. We have 100 of them, right? Then the output, then we have one dense layer with two neurons. So there are two neurons like that, and this dense layer is there. So something like this, right? And then we have sigmoid function on top of it. So this is where you can say auto, and this one is representing the home loan, right? Insurance of the home loan. So auto and home loan. So this is a representation of the DNN which we are creating over there. So if I take you back to it, we have the embedding layer. There is a dropout of 20% here, and there is a dropout of recurrent dropout. So this 20% dropout basically means like we have a dropout in input or output as such. The recurrent dropout means that we are doing the dropout in the LSTM units as such. So there are two different type of dropouts. If you have worked with other neural networks, the dropout, you may not have seen the recurrent dropout separately from the dropout. It might be the same concept over there, like just the dropout layer. It's basically used for regularization as such. And basically we do it so just to make sure that the model doesn't overfit in the when you are training it. So we are putting dropouts over there. Then we are putting dense layers and sigmoid. Now, how do you put it together? Like this is the DNN part, but we have to train it. If we go back to the example which we are doing, the regularization, the training of the model is supposed to be done in the compute target. So if I take you back to my let me see, where is it? Mm, oh, let me zoom out once. Let me find the compute cluster. Okay, see, notice this. So we have written the code in the compute instance. That's where the train.py file is there, the training file. This is the target where we are doing the training right now. This is the you can say training target like this. So we have to remote submit the job. So this is where the submit of the job will happen like this, remote submit. uh, right, and then the training will happen there, and the model needs to be registered. So what do? We create one train.py file. So this is the train.py file. This is not running right now. It is only locally saved as such. We are naming this file as train.py. You can give it any other name. The logic is basically you uh, do the remote submit. Now this is what we have. So later on we'll create one context. In that context we'll specify that. So this is where the previous part again comes back. We have to create the environment. So we are saying that okay, there is one ready-made curated environment called as uh, Azure ML TensorFlow 2.2 CPU. Let's use it. And in that we are cloning that. uh, we'll name it as custom TensorFlow environment. As soon as we do that, it will, if we go back to the environment part, you will see that it is already registered by that point, right? This one. Now in this custom environment, we are adding NumPy. We are also adding scikit-learn over there as well, right? So this environment, the train.py file, is what we are putting. So okay, now here this is where we are creating this script run configuration. We are specifying in which folder the train.py file exists. Uh, the name of the file is literally train.py as such. What is the input folder? Input folder means where's the data, right? That data as well. What is the learning rate, batch size, how many epochs are we looking for, where do we have to train it, which environment do we require? So once we create this script run config, we submit it. So something like this, like we say, we create one experiment. As part of the experiment, the run will happen. What is experiment? Experiment means that that location where all the runs will be there. So if I take you back to my example, in this experiment part, you will see we have this claim classification experiment, which is exactly this name which we gave here, claim classification experiment. Now that, so all the runs which are going on are part of it. So if I click on it, you will notice that we have this run which is successful as such. And if I just click on it, uh, right, and maybe zoom out slightly, you will notice that it is having all the details, like some matrices are there. When did the run happened? It ran for how much minutes? Minimum accuracy was there. What was the loss as such? Where did it ran? What are the matrices which were there? Accuracy matrix was there, loss was there. uh, any child runs if they happened. Outputs, where are the outputs? You notice this file, this folder, outputs over here, this one. You see this final model.htf5 over here. This is the saved model, this is a trained saved model. So if I take you back to my training script, you will notice in the training script we have uh, somewhere over here. Yeah, check this out. So we are saving it locally. So now the good thing is, for the data scientist, even when they do the remote submit, they have a local file format over there where they can save it. If they save the particular model there, it's going to show in the experiments. So experiments is that single sort of umbrella, you can say, where everything happens. All the runs will be there, all the information will be there. You do the logging as such. You can use ML flow for the logging. You can use the default logging mechanism uh, in Azure ML uh, to uh, for troubleshooting purpose, basically, to be able to understand what's the output of the matrices. So this is the trained model which we are which is got trained and it's saved over there. Now what we want to do is we want to basically register that. So if I show you that it ran for some time over here, just want to show you the oh, let me see. The model doesn't exist. We can see the model there. uh, Let me see. Give me a second. Does not exist at output final model. Okay. But the, let me just see. Let me zoom out slightly and have a look at it. Let me see what happens as such. I, I thought I ran it all, but I think that didn't ran. Okay, no problem. So this is the, basically we are just having the summarization of the model. So if you notice, we have this the output of the LSTM layer is 100. The embeddings are 125 is the vector length. The meaning of 125 is that the input which is coming will be converted into a length of 125 vectors. So if I just show you that 125 part, I have it somewhere in the note in this file over here. Just give me a second. Let me quickly show that. Pretty interesting concept. So you will notice that we have all these zeros and like this. So this is the max sequence length 125. So if the input statement is that the pedestrian basically hit me and went under my car, pretty grim over there. But if that is the statement, then it is converted into this vector which is of 125 length. And this is where we have the, like, all the zeros are there. And the pedestrian hit me, went under my car is pointing to one of the dictionary which is created in this example, and the numbers are basically the index values of it. So this pedestrian is basically on index number 13519, hit is basically on the index 416, me is on the index 285. Index of what? Index of the embedding layer. So this is where if I just take you back to my example, you see over here we are using this embedding layer. So now there are two options. You can train your own embedding, you can use something which is pre-existing. So there is a one which is trained by Stanford called as global vector representation as such. So we are using that. So if I just take you to the documentation of that, this is what we are using there. Now in text analytics, it is amazing if you can do mathematical operations on top of the text values. That is something which is amazing. How do you do that? So if you see this example over here, Now, what globe basically is, it has given one vector, you can say embedding or vector representation to every word. There are around 400,000 words over there, and those 400,000 words are having the vector representation. So, for example, this uncle, woman, man, queen, king will be having some vector equivalent representation of it. So, and the way it is designed is that, for example, if we do, let's say, king minus men plus woman, the answer should be queen, like that. So uh, so if I show the same thing to you, like how do we do it, I'll just take you back to my code, and I have it over here uh, as well, to show that part to you, that how interesting it is. Just give me a second. Yeah, so please notice this. So once you use glove, we have this father, mother, king over there. So the vector representing father looks like this. It is having the sequence is of 50 characters right now. The 50 is the length of the sequence. The vector representing mother is over here, like that, and the vector representing king is over here, like this. Now, what global vector representation let you do is do mathematical operations. So if I subtract anything from anything, it will be similar to another vector. Now, what we are doing is we are saying a mother minus father plus king. Let's put it like that. So mother minus father plus king. Okay. Okay, so this is equal to x, and then what do? We add queen to it, like we add woman to it, I think, which is basically in one of the cells below it. So this is mother minus father plus king. Now we want to find cosine similarity of it. So cosine similarity is something which we use in the text analytics to be able to find some documents which are similar, to be find some vectors which are similar, to find some words which are similar. So if you want to find synonyms, if I give you, let's say, frog, and you want to find the synonyms of it, so it is similar to, let's say, toad, it is similar to lizard, it is similar to other words. So if the vectors are similar, uh, we can, so if you have one word and the vector of it, we can find other vectors and we can find other synonyms as such. Similarly, if you have any opposite words also, we can totally find that. So if you notice, what we are doing is we are trying to find that if I do mother minus father plus king, and the vector representations are these, if we do the subtraction and the addition over there, it is similar to what? So we have given few of the search space is not infinite, it will take more time because the words are 400,000 words are there. So we have given a search space over here of basically woman, prince, princess, England, empress, sky, machine, learning, and fairy, and so on and so forth. So what we are doing is we are finding the cosine similarity. Now, if you know the range of cosine from -1 to 1, like that, right? So if something is towards 1, it is similar. If it is towards -1, it is totally opposite. Like they are totally different words altogether. Now we find the cosine similarity of x to these which are there in the globe. So the output is this, that the most similar vector x is most similar to queen. The cosine similarity is 0.877, which is towards 1. The princess is next, 0.77, makes sense. Prince is 0.75. Okay. uh, and so on and so forth. We have a lot of words. Machine is, it doesn't make sense. It is very less similar to it, so more dissimilar than similar. So cosine similarity is what is being used to find the synonym. So in case, uh, in your insurance claim model, in case in your insurance claim detection system, if somebody use synonyms, if they use any dictionary words, if they use any other words as such, uh, we can also train this for slangs. Like, you really have to train your own embedding, but you can, it can be done. So then the if even if somebody uses slang, we will be able to identify what is this similar to, and then we can say that, okay, this is simply auto insurance claim, this is simply home insurance claim. Now this cosine similarity which we have done, we test it out. Like, this is where we are testing it out. I'll just take you back to the to the part where we deploy this. Uh, if I just take you back to the part where we were running, we was doing the submit of the model. Yeah, over here. So the run has been done. The output is there, and this is the output model. We are saving the model as this final model dot hdf5, uh, and then this, and we can test it out. Like you want this is right now we are doing local testing, so the data is there, and let's see what the model predicts. So the model is saying that the first statement which is there, let's read the first statement. I crashed my car into a pole. So the model is saying that it is basically class 0 as such. Sorry, this is basically class 1. It is having 0.99 probability towards one class, and the output level is also 1. For the second statement, it is saying the flood ruined my house over there. So class 0, right? Makes sense. Home insurance. One was the car insurance, auto insurance. I lost my car and fell in the river. uh, Now this is basically again going in the, you can say, the auto insurance part, like that. So the model is predicting whether if somebody puts this text versus that text, in which class are we putting it over there. Now what we want is that this is right now running locally. We want it to be deployed in production. So we go back to the same logic which we have discussed, that if you save this model, you can deploy this model as part of a web service which can be called over the API calls. So this is, we go back to ACI, we create that green color ACI instance, we put the model over there, we let the functions do the scoring with it. I'll just take few questions from the chat in the meantime. Okay, so there's some discussion going on in the chat. uh, what exactly do dropouts, what is that dropout? uh, See, uh, so check this out. Now, I'll give you one scenario, right? Imagine this. So let's say all your pictures are there. You are training some, you're creating an image classifier. You are giving your own pictures as such, and this is basically maybe a face classifier. This person versus that person. Now, in your pictures, the background was always red. The background was always red. Uh, right, you may have taken the pictures on different days, but the background was always red. Or maybe there was a specific type of background, always there was a wall. Maybe you were always wearing the gray shirt, or you were always wearing some particular type of clothes as such. So what machine learning model may end up doing is it may relate you to the background, it may relate you to your shirt color, it may not relate you to your facial features as such. It may, we don't want that. We don't want the machine learning model to be getting trained so specifically on one particular feature that it is not considering the other ones. So what we do the dropout. So we randomly uh, drop few features, we randomly drop few neurons when the training happens. So what it will help us in doing is it will make sure train the model doesn't get overfitted to one particular, it's not too biased towards one particular feature. It does the regularization as such, and it doesn't learn that your red t-shirt is what it doesn't relate you with the red t-shirt. It maybe in that particular, when the model is training, that red part of the feature extraction, where the red concept was extracted for the input, will be dropped out, and still the model is supposed to classify you as you. So the dropout will make sure that your models are not biased towards few features. It will make sure that uh, we can have, you can say, a better model training like this. So that's the reason of doing dropouts. And right, so I'll just take go back to what I was discussing. And right, so if I just take you guys back, so what we are doing, we will just quickly, okay, I think now the model exists. So the code remains same. I'll just tell you the deltas now. Let me just run it once. It will take long time to run. So the trained deep neural network is now being deployed inside the ACI. Uh, this is where there is one more concept which we have to discuss. It is called as Open Neural Network Exchange, ONX as such. So it's what is ONX and what how do we use it? Where do we use it? What do we do with it? So this was one of the project which was initiated by Microsoft and then it open sourced later on. The concept is that we try to provide the uh, see if you deploy your ML model in an IoT device or you deploy the ML model in uh, in a mobile app, or maybe you run it in your browser or you run it in the cloud, it will require some dependencies to be there. If I train the model in TensorFlow is supposed to be there in the deployment target for me to load the model and then work with it. If I train the model in using let's say if I'm using NumPy, I'm using pandas, I'm using maybe scikit-learn, that scikit-learn is supposed to be there in the deployment targets for us to be able to further uh, use it. Now what Open Neural Network Exchange does, it I'll just put it here, it recompiles the model into another format which is now platform independent. So I'll just put it like this. So earlier what we were doing, let's say the data scientist is using this TensorFlow to train the model, right? And this model is now deployed in the IoT edge over there. So in this IoT edge device, I need some maybe TensorFlow Lite, or I need some, you can say, some dependency will be there to load the TensorFlow model to consume the model there. Similarly, if we deploy this in a mobile app, so let's say over here in this mobile app, now here also you need some dependencies to be there. What happens if I have PyTorch? Then I have to basically do the same thing. The dependency will be totally different for this scenario, and it may be different for that scenario also. Now instead of having um, so now what we are doing is that we are training the model and then we have to maintain the dependencies in the deployment targets also. So what Open Neural Network Exchange does, instead of doing that, we recompile various models into ONX format. So there is a recompile, so we recompile now like this, right? So format change will happen, and this is that ONX like this. And now it doesn't matter, we just need to have the ONX runtime. So you don't need to have TensorFlow in this IoT device, you don't need to have PyTorch in the IoT device, you just need ONX runtime. So runtime. Now, what ONX is doing, it is making the deployment more smoother. It is making the entire process more streamlined. We are the data scientists are abstracted from the dependency management now. They just have to, and they don't even have to, they may not even have to relay it to the people who are deploying it. They will just, they always know it, it's supposed to be ONX runtime. That's, it doesn't matter you trained it in TensorFlow, you trained it in CNTK, you trained it somewhere else, we just have to put the ONX runtime in the deployment targets and the model will run over there. Now the second thing it does, so first thing is like it now we don't have to do the dependency management which we were doing earlier. Second thing is that Open Neural Network Exchange speeds up the inferencing. Now there is, it speeds up more than two times like that. Like in some scenarios there will be a speed up of 10 times. In some scenarios I have literally seen speed up of 200 times as well. So if I do the inferencing against a TensorFlow model, or if I have that pickle file against which we are doing the inferencing, uh, the it will be slower versus having that converted into ONX and then doing the inferencing against that. So if I take you back to my notepad, so sorry, notebook over here, what we are doing is we are testing it out, like whether it makes sense or not. So it is still training. So what I'll do, I'll just go back to my backup, which I already have it running somewhere. So this one, oh, not this one. Yeah, this machine learning workspace, that one. I'll just take you to my already trained and deployed model, which should be inside this one. And you will notice that if we do not recompile the model into Open Neural Network Exchange, then it is five times slower. So I will just take you back to the hands-on notebooks and more notebook number 4. Okay, so we are converting the Keras model into ONX, and basically there is a step like you load it, you convert to ONX, and so on and so forth, and then we will compare which is running faster. So if I take you to the you can say the time which both of them took. So when we did the scoring against the Keras model, the scoring was done in around 33 seconds, like that. Oh, sorry, this is 33. Okay, the unit is not very clear, but it took like so. Okay, so if you notice, the ONX is basically doing the same thing it in 3 time units, 6 time units as such. So ONX is coming out to be 5 times faster than Keras in this particular example. So if you use this Open Neural Network Exchange, there are two good things which are happening. First, dependencies are abstracted. Second, the inferencing is faster. So when you are looking for those, you can say, when you're looking for the you can say millisecond, so when you are fighting for that milliseconds, when you are deploying something on the IoT edge and you are saying that it should be as fast as possible, then just converting that into ONX model will give you that edge as such. So what do? We are converting the Keras model into ONX, and then we are doing the deployment into ACI. So then the logic remains same. We sort of create the scoring file, score.py file. Initialization function is there. There is a run function is will also be there, this one, and any other pre-processing you want to do on the data, and then we package everything into ACI, and then we deploy it. So we have the dependencies over here, NumPy, TensorFlow, ONX runtime is there, Azure ML SDK, Azure ML defaults, pandas, uh, as such. Then we do the model.deploy, and then we are waiting for the deployment to happen, and that model gets deployed in the ACI. So it is basically uh, running as the web service where we can do this scoring, this part, and it is a binary classifier comparing auto versus home, auto claim and home. So auto is that one class, and this home will be that 0 classes. So using the custom machine learning model, this is what we are suggesting to be provided to uh, Contoso Insurance for their text classification problem statement. Let me go through the questions once, and then I'll tell you the third part which we are doing, the sentiment analysis, right? And that will be the last, we can say, uh, problem statement for which we are trying to solve for the customer using the pre-built AI. So this will be easier. Like there literally will be, we'll just have some pre-built AIs. We'll use the keys and we'll start deploying them. So if I go through the chat window, yeah, I think the last question is anyways the dropout only. So if anyone, if you have any question as such, anything which comes to mind, anything you want me to repeat, uh, anything which is uh, you can say, yeah, it might be a little more to digest, but definitely when you redo the workshop, it will be pretty straightforward to work with. So put your questions in the chat window, and in the meantime, I'll just open the sentiment analysis pages in my Azure portal to show you what we are doing over there, right? This part. So I'm just going to my Azure portal, and I just want to go to my resource groups, and I will go to this the deep learning workshop resource group, and I just want to click on the cognitive services as such. So we have deployed two cognitive services. This is computer vision, and the other one is called as text analytics, which is here. uh, yeah, ta shivam, like that, text analytics, like this. So these are part of pre-build AI. Things are already there, we have to use it. Now if you want to do an API call, you basically needs the key and the endpoints. So this is where we have the keys right now. So if I just show the keys, like that's my key one, key two. One is what you have to use, other one is just redundancy, and the endpoint is the one where we have to do the API call. Similarly for the text analytics also same thing happens. Like we have, uh, if I just click on the key, so like key one, key two, and some endpoints are there. What I will do, I will just quickly show you this part here. Notice this. So before I run you through the Python code, I just want to clarify what is this computer vision doing over there. Now, yeah. So basically, see, when it comes to vision, we can do multiple things like semantic segmentation of images. You want to do maybe object detection, you want to summarize it, you want to put some tags what is going inside the picture. So if I just show you this example, this is one picture, and if you check out the output values which we are getting in this, which we will finally get in the JSON format, but if you look at this, it is putting that there is a train, makes sense. Confidence of train is 0.99, pretty confident that the train is there. This confidence help us in when the model is not confident. You can put a threshold over there. You can say if the model output is not beyond this point, then ask more information from the customer. Maybe you will say that this your picture for the claim insurance doesn't look good, take another picture. Why? Because the model's confidence was low on the picture. Maybe lighting issues, maybe there is interclass variation, maybe some sort of the object is getting is hidden as such, or maybe the picture is too zoomed in, zoomed out. So whatever the reason is, that if the confidence is low, you can just catch that exception and you can ask the customer to re-upload it, re-upload the picture again with, take a better picture, like that. So right now on that input we are getting some confidence is there, like that there is a train, platform is there, station is there, indoor, subway, clothing, person, something is pulling. I think they are pulling their bags or something. Maybe there is something else also. So what else can we do? We can summarize the picture as well. So for example, if you see this picture over here, there will be some summary as well. Like see, a group of people sitting at a table using laptop, confidence is pretty high, uh 0.96, right? 96% confident that it's this what it says. So which is, yeah, correct. They are sitting at the table, sipping some coffee and having, and sitting with a laptop on the table and all that. Other things which we can do is we can do OCR as well. So if I just click on the on this picture, whatever is there in the image can be extracted as well. So something like that, right? So if you say you must be the change in the world which you see, so you must be the change, and it is able to extract that. Now this all these functionalities, OCR, we are summarizing the we are putting some tags on the pictures, object detection, all of this is part of the computer vision cognitive service. Now the other one which which we are using is text analytics, over here. So if you remember, when we were reading the requirement of the customer, they were asking two things. They were saying that uh, the pictures, the claims are stored in the database, but the supporting pictures and the text are going in the object storage, and there is no link between that. So if you can you can say tag the pictures, if you can extract some information from it, maybe the number plate information and so on and so forth, it will be easier for us to create index on top of it, right? Second thing is uh, text analytics. In text analytics, now this is where we have these text like sentiment analysis. Now I'm pretty sure you guys already know sentiment analysis, but just whenever we are getting the sentiment analysis, there are a few things which can be done. You will get the score of the entire paragraph as well, like the entire document. You will also get a line by line score. Sometimes what happens when you have to extract the feedback from the entire, when you have to extract the information from the entire feedback, it is important you find the point which is where the customer is putting negative sentiment, like the food was great but the food came very late. So the the feedback for the business will be that you should focus more on your on the delivery as such, on the service as such, that you maybe you put the food as fast as possible on the table over there. So we want the full document score as well, plus line by line score. So that's what we are getting in the sentiment analysis service. The score will be between 0 and 1. 1 is like very positive statement, 0 is like a pretty negative statement. So if you notice that in this entire example, this is the preset example as such, but if you notice that they went to the they went to a restaurant, they had a very amazing dinner party, they loved the food, food was amazing, great menu, everything was amazing, the owner also is super. But see the second last line, the only complaint I have is the food didn't came fast enough. The food didn't came fast, everything else is amazing about the restaurant, but the food is not fast enough. So uh, okay, so okay, overall document 80% positive overall, right? Sentence 1 positive, sentence 2 positive, 3 positive, 4 positive, 5 positive, second last is supposed to be negative, right? So last is eighth, second last is this seventh. So seventh, second last statement is negative, 100% negative. Like the only complaint I have is the food didn't came fast enough. So if this is what you can extract from this review put by the customer, the business can take a call on it. Business can improve where the points are weak. The same thing can happen in your company as well. If the people are leaving the company, there might be a reason behind it. And if you, from the feedback which they are putting on the glass door, if you extract that feedback and you can provide that service, that you are extracting the information from various social media platforms and telling the HR team back again that this is what you have to change, that's why the people are leaving your company, right? That's why the employees are leaving the company. It's not about the money, maybe it's not about the manager or maybe whatever, but that's the reason behind it. So we also want to use this cognitive service called as text analytics. There is one question on the chat: does OCR works for Indian languages? The OCR works for Indian languages. There is a support for it, I can check it for you. uh, So when the code will be running, I'll just go and have a look for it. Perfect. On the right time, there is a link in the chat where the entire list of supported languages are there. Uh, they might have added more, but there are multiple languages as such which can be seen. Uh, and if the list has further, you can say, is pretty long. Last time I remember the list was slightly smaller than that, but if you see the uh, uh, we have so Indian dialect is what you were looking for. So that's a pretty long list. So have a look at this. So yeah, I don't see Indian languages yet as such, or maybe I skipped it, but just have a look at it. Go in and check it out. So it's a long list. So the good thing
There
is,
is Hindi,
oh, there
there
is
is
Hindi there.
Hindi and other things. Yeah.
Oh, okay, okay. So Hindi is there. Maybe I didn't have a look at it. So Hindi is supported. Now, if I just take you back to what we were discussing, uh, okay, check this out. So what we want is that using the cognitive services, we want to take out the information from the supporting pictures uploaded by the customer when the accident happens, right? That's the main logic. So let me take you back to the one of my notebook here where we are doing it. Okay, check this out. So this is the part where both comes together. I'll show you the output first just to create that interest as such. We are combining both the pre-built and the custom AI services together. So if I just take you to it, notice this. So in the end of the day, the picture which was uploaded by the customer looked like that. There was one NYPD truck was there, and it was picking up the car, and maybe this is after the accident as such, right? So if you see the when we combine the custom with pre-built AI, that's what we get. So the classification is auto insurance claim, right? This is that custom AI model is putting. The caption is a police car parked on the street car. This is the caption of the image. The tags are road, outdoor, car, right? Text image NYPD, like this. Sentiment negative. Okay. This is why it is negative. So there's a summary of it. Like after hitting my car, the black sedan basically backed up and it ran away, and the license plate is that. So this is basically coming from the Gensim web service which we deployed first. Now, what was the claim? This is where the sentiment is negative, right? So I was dry. This is the same statement which we have read before. The right light was red. It was 3 p.m. The guy behind me didn't saw the light, uh, hit me from behind, and the license plate is ABC 123. So this is really, you can say, cutting edge for Contoso insurance. Their entire requirement is satisfied. They were looking for us to first tell whether AI is hyped or not. Maybe AI is hyped or not, but still, in this particular requirement, everything is getting satisfied. They wanted the classification done, caption of the image possible with the pre-built AI. We don't even need to create the custom AI. Tagging done, OCR done, sentiment analysis negative. So we should give more preference to this customer. We should before the customer goes viral, the claim goes viral on maybe on social media, we can cater this customer. Summary and the details of the claim. So how do you do it? So the custom AI is what we discussed previously. Now the pre-built AI is pretty straightforward. The few information which we require will be the API keys. No, I am not saying you hard code your keys over here. In this example, I have hard coded the keys. In production, you will put your keys in key vault, and basically from the key vault, the key will be pulled, and then sort of you can say uh, it becomes better, more secure, right? Or maybe in the configuration file we can at least put it, but Azure Key Vault can be used if instead of hard coding it. But for now we are focusing on the ML part, so we are hard coding it over there. So if you see that we are hitting the my cognitive service which is deployed in my subscription, and if you and the pricing will be API call based. So if I use it, I pay for it. If I don't use it, I don't pay for it. And there are few pictures which we are using for the uh, you can say for the testing purpose. So this is the picture which is provided over here, where the car is damaged as well. Maybe this is the damage over here. Oh, it was somewhere, I think, on this car. Now if I show you the tagging which was done, so check out the tags which were returned as such. So road confidence is .99, outdoor vehicle, land vehicle, tree, car, wheel, street, truck, police, text, tire, auto part, emergency vehicle. So if you create an index on top of it using Azure Search, and you are looking for all the claims which were done in this week in this area where the car was hit, then now the search can be done in that object storage using Azure Search, and the values can be fetched way faster. We'll have the index created on top of it. Why were we not able to do it earlier? Because we didn't have the captions. If you put any human being to put the captions over there, two things will happen. Either it will, first of all, it will take time, right? And if the images are pretty big, the system is not automated or it's really manual, so it will take a longer time. Secondly, the humans may also make a mistake, and they may tag it wrong as such. So by having the ML model put the tags over there, you can also do the cross check to what humans have done as such. Now, or vice versa, you want to check out what model is doing. So if we take out the tags, these are the tags without the confidence score. Now the caption which is being put is a police car is parked on the city street, which is actually pretty accurate because that car is not in the picture, not much in the picture right now. So this person should take another picture supporting it. Now, if I just take you further, so we are also performing OCR. So what we are planning is that anything which is there in the picture will be pulled out. So this NYPD, uh, the number of the car is not visible. At least to me, it's not visible that much. But if possible, that can also could have also been picked out from there. Uh, like that. So if I just go to the OCR part, you will notice that it is picking up, it is putting few boxes as such where it found the data, and one of the text which it found is this NYPD as such, which is pretty visible in the picture. Now over there. So then we are doing sentiment analysis with text analytics service, and we are putting the key and we are using the other second endpoint to do the sentiment scoring. Score will come between 0 and 1. So this is there are three statements which we are putting right now. Literally, we know first statement is negative. We know second statement is somewhat neutral. I crashed my car. I'm like that. And the third is a longer statement where we are expecting line by line uh, sort of result back and the overall summary of the document as well. So negative sentiment, positive, and long claim. So if we put the long claim over there, you will notice it is saying that the language is English, text has been the you can say has been done, and if you check this out, so uh, it's basically negative. Okay, so negative statement, and then sentence of one sentence is neutral. So this sentence over here was driving down the road is neutral, and then it breaks it down. See that the sun was bright and shining behind the stoplight. This is uh, sort of maybe little bit towards neutral or negative, like not really negative as such, like somewhat you can say on the negative side. And if we just go further down the line, you are seeing that the after hitting my car, the car ran away and so on and so forth. So the various statements are coming up, like positive negative statements are coming up. So somewhat negativity is there in few statements, some of them are positive, some of them are mixed. So here everything is there, like this statement is having 0.09% positivity, 0.09 negativity, and mostly neutral, 80% neutral statement. So uh, and then using all the summarization, all the three things together, we are able to create, we can put the outputs in different locations, but this is the summary as such. uh, Classification, captioning, tagging, text, OCR, sentiment analysis, summarization, and claim. So this is the final solution for contoso insurance. This is what we were planning since the starting, that we will be looking for that computer vision, we will be looking for text classification, sentiment analysis. uh, we focus on the ML part. We don't even have time for the SQL, but SQL and pictures will go in that storage account. Uh, Pre-processing can be done. Training of the models. We trained one LSTM model today, uh, and two cognitive services and one pre-processing service. So this is the requirement for the customer, and there are just few objections which we will handle, and then that's what we have sort of there. Now, there was one pretty interesting point, if you remember, that customer was asking about, should we go for CNTK? Should we go for uh, TensorFlow? What should we go for? So if I just take you to that point right away, it's pretty straightforward. Let me see, where have I put it? Okay, so let me just quickly try to hit it. Yeah, okay. So now, yeah, so see, Whenever you work with machine learning, now there was one question in the chat saying which programming languages are supported. To be honest, there is a huge list of programming languages which will be supported. The most common ones will be like Python and R, which you might have heard are the most popular one, because Python is the versatile one. You can do pre-processing. We have the most community support surrounding it. Most of the libraries are first came in Python, then they comes in any other. So they support any other language as such. So it depends on whether your team is having that particular composition or not. So for example, the TensorFlow community is way stronger than the CNTK community today. So if I go for TensorFlow, then one thing which will happen is I will find the resources easily, I will find the support documents easily. The if there are any bugs, we'll find how to resolve it, or we'll find the solutions of it. The on Stack Overflow, they will be uh, sort of everything which you're looking for might already be solved by somebody. So looking at there are multiple language support, looking at your team's composition, looking at uh, what is easier for the developer community to follow. You may select one programming language, one framework, and you may stick with it, or you may try some things later on. So that is a soft reason behind it, what you can go for. Now, there is a question in the chat saying, uh, how do you identify the biases? Are there any biases to overcome? Now, when it comes to biases, there may be we there is a concept in Azure Machine Learning service called as uh, like fairness. How fair is your model? Is your model biased towards one gender? Is your model biased towards one community? Is your gender biased towards maybe the youngs are getting the loan, the olds are not getting the loan, or vice versa, right? Is it biased or not? We have multiple ways of finding it out. You find it, like basically you have to find it. So basically we have things like there is one thing called as uh, local feature importance and global feature importance. Like why so in local feature importance, what happens when we get the output, why it came. If the person got the loan, why they got the loan, what was the reason? Was their income high or low? Was it the gender, male or female, or was it the salary was having some particular range? What was their civil score? What was their maybe uh, any specific reason behind it? So yes, there are models available. There are ways available in AML service by which we can do we can understand what the models are doing, and based on that we can understand whether it is more biased or not. There we have fairness policies using which it can be achieved. So put your questions in the chat. This is what we had for the Contoso insurance, and that's what we have discussed. I'll take your questions now, and those who want to reproduce this entire demo for you, the link was already in the chat. You can go back and have a look at it and do that.
By the way, you can check in and get the all the learnings. You can There is a link which has been provided for check in the use the code and check in, and you will get all the learning modules which is related to this specific topic today. That's the link to check in, and that's the ID you need to put in. Any more questions, or Rashmita, we can we're waiting for some more
Do
questions though.
Yeah, let us just wait for another 5 minutes.
Okay, so there is one question: how do you ensure low code or no code? How to ensure? Um, we have in Azure Machine Learning Service we have Designer. It's literally nearly no code. you can drag and drop and start from it. So if and the time it takes to release something in production is very low in that. So if you are beginning with the ML platform, you can go for designer. There is one question saying health analytics. I'm confused how to start. I just want to find out some symptoms related analysis. Okay. Looks like classification is what you are thinking of, like as such. Do you? We have that very the diabetic or non-diabetic PMA diabetic data set, right? You must have seen those. Start from there. Uh, Check out the logic behind the sigmoid function, how that logistic regression works. That can be one of the starting point.
Thank you, folks. By the way, there is Azure Developer League as well, which is happening. It's more of hackathons and hands-on sessions and cloud skill challenges are running. So do check out that link which has been just posted and take part. There are some more questions which are coming in. Yeah, sure. I mean, Azure Developer League is is basically a place and hub for you for learning. So Shivam has opened it. This is one of the cloud skill challenge which we are running for this specific session, but there are other cloud skill challenges which are running. There is hackathons which is running, and it's an ongoing process. Like it's basically you are attending, uh, you know, end to end learning for just not just for cognitive services, but also for the GitHub actions for your developer related things, Kubernetes, cloud native. There's a lot of learning out there, so just check out that link. You'll be able to figure it out. Shivam, if you can just open the Azure Developer League as well, the link. Yeah, that's the one. So there is cloud skill challenge, there is hands-on learnings and hackathons. So hands-on learnings are nothing but the workshops which we are doing. So there is upcoming workshops which is there. Those are the things, and there is hackathon which will be launched as well. Okay, Rashmita, I think we can break and you can keep ask. People can ask questions, and Shivam is there. He'll be able to reply on YouTube as well.
Mm, okay. I think, yeah, that's about it. So thank you, Shivam, and thank you, Vivek, so much. And thank you all for joining us today. Hope you all enjoyed today's session. Please do share your feedback with us. It will help us choose topics that better suit our audiences. Also, if you haven't done the event check in, please feel free to do. It will help us, to get all the resources. Thank you all once again and enjoy the rest of your day.
Thank you. Thanks everyone.